This question is taken from Math Problems in Real-World Context, published by Cavendish Education. This serves as a guide for the question 10 on cocktail shaker. The first part of the question wants us to find the volume of the hemisphere. So we will use the formula to find the volume of a hemisphere, which is half of that of a sphere, 4/3 pi r cubed. So you can substitute the radius 4 cm into the equation to get the answer. We'll go on to the next part. Given that the volume of the cylinder is equal to 3 times the volume of the hemisphere, so I have a cylinder here with the same radius r equals to 4. The volume is 3 times the volume of the hemisphere. They want us to find the height of the cylinder. So I will need to equate the volume of the cylinder to 3 times the volume of the hemisphere. And then if I were to substitute r equals to 4, I'll be able to find the height of the cylinder. Now I'll leave you to find the height of the cylinder. For part C, the diagram shows the cocktail shaker filled with a liquid to a depth of 7 cm. Now knowing this, since I know that the radius of the hemisphere is 4 cm, it would mean that the cocktail shaker fills the cylinder to a depth of 3 cm. Let's go on to the question. Now part 1 wants us to find the surface area of the inside of the cocktail shaker that is in contact with the liquid. So if I were to go back to the diagram, I see that the surface area that is in contact with the liquid would actually consist of the curved surface area of the hemisphere and this curved surface area of the cylinder. So let us jot that down. So writing it down, curved surface area of the hemisphere is half of the curved surface area of a sphere, which is half times 4 pi r squared, where the radius is 4. The curved surface area of the cylinder, which covers the 3 cm height, would be 2 pi r height, where r is 4 and h is 3. So I'll leave you to calculate the value of the surface area that is in contact with the liquid. Let's go on to the next part. We need to find the volume of liquid in the cocktail shaker. So the volume of liquid is the volume of the hemisphere plus volume of cylinder. Volume of hemisphere is found in the first part of the question. The volume of a cylinder is given by pi r square height. So I substitute the radius and the height, and I'll leave you to find the value. We'll go on to the third part. The cocktail shaker is geometrically similar to a smaller cocktail shaker. Both cocktail shakers are made of the same material, and the diameter of the base of the smaller cocktail shaker is now 6 cm. What we have here, the diameter of this cocktail shaker is 8 cm. Given that the mass of the larger cocktail shaker is 3 kg, find the mass of the smaller cocktail shaker. Now for this question, since I know that they are geometrically similar, I'll be able to compare the mass by comparing the volumes of these two geometrically similar shakers. So the mass is, the ratio of the mass is equivalent to the ratio of the volume, because they tell us that the shakers are made of the same material. So I'm assuming that the density of both shakers are the same. So in this case, the mass of the larger cocktail shaker is 3 kg. So M1 over 3 kg would be the ratio of their lengths. So in this case, I have the ratio of the diameter. The smaller cocktail shaker has a diameter of 6. The larger one, which is the one that we have been working on for this question, has radius of 4. So the diameter is 8. And then you'll be able to find the mass of the smaller cocktail shaker. For part 4, 20 ice cubes are put into the cocktail shaker. The length of the edge of each ice cube is 1.5 cm. Will the liquid flow over the cocktail shaker after all the ice cubes have melted? Let us first find the volume of space that is left over in the cocktail shaker. So from part B, we have found the height of the cylinder to be 8 cm. So this leaves us with a height of 5 cm. So doing our working, we will get this answer for the volume that is left over. We will now go on to find the volume of 20 ice cubes. The volume of 20 ice cubes is 67.5 cm cube, which is actually much lesser than the volume left in the cocktail shaker. Therefore, the liquid will definitely not overflow after all the ice cubes have melted. Now in the real life, the volume of the ice cubes will actually be more than the liquid that is used to form these ice cubes, because when liquid melts, it actually expands in volume. So the amount of liquid will actually be lesser than 67.5. Now, but in this case, we don't really need to consider that as well, since the volume of 20 ice cubes is much lesser than the volume that is left over. So the cocktail shaker can definitely take 20 more ice cubes without fearing of overflowing. So I will do a comparison with the volume, and I will write down my conclusion to answer the question. This will be my answer for this question.